Okay, so last screencast, and we're going to look at Ancova, or analysis of covariance. So far, we can have multiple continuous predictors, and we can have now multiple categorical predictors. But what if you want to have a continuous predictor and a categorical predictor at the same time? Well, this is what we call analysis of covariance. So here's my motivating example. We're looking at the MPG data set. What I've done here is I've done a scatter plot of fuel efficiency against displacement. And we see we've got a decreasing, moderately strong, non-linear relationship. But we have more information. What if we take into account the transmission? What if we look at these between auto and manual? And you can say, well, let's assume that we've got a linear regression, we want to fit a model. Could I actually fit separate models for each one, or should I have one model for all the data? And Ancova lets us explore this. So we're going to consider three types of models. The first one, the identical regression, says we have one regression line for all the data. So it's of the form of yij equals beta 0 plus beta 1 xij plus epsilon ij, where in this case our I is the level of the categorical variable, in this case our manual automatic, and our j would be the observation within each group. So this is just a straight line. We have this one intercept, one slope, all fine. The next step up is we can go, well, why don't we have, instead of the same line, we have two lines that are parallel to one another. So notice they have the same slope, but they have a different intercept, one for each level of the categorical variable. The final one is a separate regression, where now we have a separate intercept for each level of the categorical variable, and we also have a separate slope for each level of the categorical. So this one, two lines that are parallel, this, they don't have to be parallel. So let's see how we do it. So here's my model matrix to show you the design matrix in the case that we're now going to use our fuel efficiency and we're just going to regress it on displacement. So this is your identical regression. And here's your design matrix. The first is just a column of ones for your intercept. And this one is basically the displacement you observe for each subject. So in this case, for the first car, we had a displacement of 1.8 litres. And this is the linear model we get from that. If we fitted it, we would get an estimate of the intercept and the slope. This is just our standard linear model. But what if I add in a categorical? So now my formula is the response variable is fuel efficiency. I now have my displacement, which is a continuous quantitative random variable, and I have trans, which is a categorical. How does it deal with that? Well, it sort of steals the idea of always sitting one way ANOVA for representing categorical variables. We've got our column of ones for our intercept. We now still have the same column of the observations of displacement. And then we've got this coding where this is now one of these standard representations. Remember, transmission only has manual or auto. It's set auto as a reference level. So this column now basically says if you're manual, you have 1, if not, you're 0, hence you're an auto. So what does this model look like? Well, you can see here we have 3 columns, so there should be 3 coefficients. You've got your intercept, plus you've got your beta 1, and this is your I1. This is basically the level of your first predictor. And it's just added in an extra column here where you've got this I2, but this is basically only going to ever take the values 0 or 1. It's going to be 0 if you're auto or 1 if you're manual. So think about it. What is the model of the manual or an automatic? Well, if you were basically equal to an automatic, this would be 0. This whole term would disappear. You'd get beta 0 plus beta 1 xi1. So you just get a simple linear regression. This would be your intercept, this would be your slope. What about if this is a manual? This would be a 1. So you'd now get beta 0 plus beta 1 xi1 plus beta 2. So you've got a new intercept. You've got a beta 0 plus beta 2 is your intercept. So beta 2 is the extra amount you add to the intercept to get your manual. Okay. What about now? We add in an interaction term. So we've now got our displacement, which is a continuous quantitative. We've got our trans, which is a categorical. And now we just add an intercept term. And it just does sort of almost the obvious thing. Here is your column of ones. Here's your column that represents the displacement. Here's your coded column, which is 0 if you're automatic, 1 if you're manual. And to get this column, it just multiplied the last two. So it went 0 times 1.8, 0. 1 times 1.8, 1.8. 2 times 1, 2. It is just multiplied. That's the interaction term. I just put this here because this is used so often as a shortcut. R has this asterisk. Asterisk says, basically, give me a main effective displacement, this column. Give me a main effective transmission, this column. And give me an interaction term as well, this column. So how did it do it? Now we've got 4 columns. We've got our intercept, we've got our displacement, we've got our categorical variable, which is transmission, and then this one is just the multiplication of the two. So now let's go through it and think about it. Remember, this I2 is a 0, 1 type variable. So let's start with automatic. If you're automatic, you get a 0. So this is going to be 0, that term disappears. This will be some number times 0, that term will disappear. You will just get beta 0 plus beta 1 xi. You just get a linear regression. This is the intercept, this is the slope. If now xi2 is 1, it's a manual, this is a 1, this is a 1. So what do you get here? You just get beta 2, here you get beta 3 xi1. So now your intercept is going to be beta 0 plus beta 2. Fine. What's your slope going to be? It's going to be beta 1. Remember here we've got beta 3 xi1, so beta 3. So your slope is now beta 1 plus beta 3. So the whole idea is that this beta 2 is the extra you add to the intercept when you go from an automatic to a manual, and the beta 3 is the extra you add to the slope when you go from an automatic to a manual. Now, how do we do the model selection? That we will do in the workshop. Cool. See you then. Bye.